Hey, we're going to be taking the integral of x squared times the square root of 1 minus x dx. Now we're going to be using u-substitution, and this problem is going to be just a little bit long, so hang in there. And it's going to be a tricky type of u-substitution. So as usual, we let what's under the radical be our u, and then we take the derivative and we get negative dx. Well, we have a dx here, but we don't have a negative out front. And then we've got this x squared that we've got to deal with. So what I'm going to do here is I'm going to solve for x. We get x is equal to 1 minus u. So in this equation here, I'm solving for x. Now because we have this negative here, we're going to go ahead and put a negative in, but we must put a negative 1 outside. Now I'm going to go ahead and do now the substitution. So I bring the negative with us. The negative, the dx, is going to get replaced with the du. And I do that, but we have to deal with this x here. And because I have x is equal to 1 minus u, I can go ahead and substitute that x for the 1 minus u. And so 1 minus u quantity squared times the square root of u. Now I want to get this u out of radical form and get it into exponential form. So I do that, and now I'm going to multiply this together here, this 1 minus u. So I have 1 minus u times 1 minus u. We pull that out. You should get u squared minus 2u plus 1. Then I'm going to distribute this u to the half across each one of these terms. And so I do. We have u to the 5 halves minus 2u to the 3 halves plus u to the half du. Now I can go ahead and take the integral, adding 1 to the exponent. We have 7 halves over 7 halves. Adding 1 to 3 halves, we have 5 halves over 5 halves. Adding 1 to a half, we have 3 halves over 3 halves, or u to the 3 halves over 3 halves. And remember, we still have this negative out front. So I do a little simplifying here, flipping that to sevenths, to fifths, and so forth. And what I do now is I factor one of our terms out here, and I'm going to factor the one that has the smallest exponent out always, and that would be u to the 3 halves. So we pull that out. Now think of it this way. If I multiplied that back inside, we would just end up with this. But we factor that out. Now the idea is I want to join this into one big single fraction, but I need to get a common denominator. And so that's where you see all this stuff coming from. And so I end up getting a common denominator, and then I factored out the 105. And so now we're left with what we've got here. I now factored a 2 out, which leaves us with a 15u squared minus 42u plus 35. And now I go ahead and substitute back in for u, which was the 1 minus x. And so now what I do here is I FOIL this out. 1 minus x squared, so that'd be 1 minus x times 1 minus x, which gives us this lovely stuff here. And I just distributed the negative 42 across. Rewrote 35. This is plus c out here, as you can see. And okay, where are we at? Distributing the 15 across, and then simplifying all of this down, collecting all of our like terms, which we end up with a 15x squared plus 12x plus 8. And then I go ahead and get it back into radical form, our final answer. So this problem was a little bit long, and it was a different type of u-substitution, kind of tricky one. Okay.